What is quantum computing, and how does it help us? The term quantum computing gained momentum in the late 20th century. These systems aim to utilize these capabilities to become highly efficient. They use quantum bits or qubits instead of the simple manipulation of ones and zeros in existing binary-based computers. These qubits also have a third state called superposition that simultaneously represents a 1 or a 0. Instead of analyzing a 1 or a 0 sequentially, superposition allows two qubits in superposition to represent four scenarios at the same time. So we are at the cusp of a computing revolution where future systems have capability beyond mathematical calculations and algorithms. Quantum computers also follow the principle of entanglement, which Albert Einstein had referred to as spooky action at a distance. Entanglement refers to the observation that the state of particles from the same quantum system cannot be described independently of each other. Even when they are separated by great distances, they are still part of the same system. Several nations, giant tech firms, universities, and startups are currently exploring quantum computing and its range of potential applications. IBM, Google, Microsoft, Amazon, and other companies are investing heavily in developing large-scale quantum computing hardware and software. Google and UCSB have a partnership to develop a 50 qubits computer, as it would represent 10 quadrillion numbers that would take a modern computer petabyte-scale memory to store. A petabyte is the unit above a terabyte and represents 1024 terabytes. It is also equivalent to 4,000 digital photos taken every day. Meanwhile, IEEE Standards Association Quantum Computing Working Group is developing two technical standards for quantum computing. One is for quantum computing definitions and nomenclature, so we can all speak the same language. The other addresses performance metrics and performance benchmarking to measure quantum computers' performance against classical computers and, ultimately, each other. If required, new standards will also be added with time. The rapid growth in the quantum tech sector over the past 5 years has been exciting. This is because quantum computing presents immense potential. For instance, a quantum system can be useful for scientists for conducting virtual experiments and sifting through vast amounts of data. Quantum algorithms like quantum parallelism can perform a large number of computations simultaneously. In contrast, quantum interference will combine their results into something meaningful and can be measured according to quantum mechanics laws. Even Chinese scientists are looking to develop quantum internet, which shall be a more secure communication system in which information is stored and transmitted with advanced cryptography. Researchers at Case Western Reserve University used quantum algorithms to transform MRI scans for cancer, allowing the scans to be performed 3 times faster and to improve their quality by 30%. In practice, this can mean patients won't need to be sedated to stay still for the length of an MRI, and physicians could track the success of chemotherapy at the earliest stages of treatment. Laboratoire de Photonique Numérique at Nanosciences of France has built a hybrid device that pairs a quantum accelerometer with a classical one and uses a high-pass filter to subtract the classical data from the quantum data. This has the potential to offer a highly precise quantum compass that would eliminate the bias and scale factor drifts commonly associated with gyroscopic components. Meanwhile, the University of Bristol has founded a quantum solution for increasing security threats. Researchers at the University of Virginia School of Medicine are working to uncover the potential quantum computers hold to help understand genetic diseases. Scientists are also using quantum computing to find a vaccine for COVID and other life-threatening diseases. In July 2017, in collaboration with commercial photonics tools provider M², Quantic demonstrated how a quantum gravimeter detects the presence of deeply hidden objects by measuring disturbances in the gravitational field. If such a device becomes practical and portable, the team believes it could become invaluable in an early warning system for predicting seismic events and tsunamis. Thank you for watching, and keep the comments coming.